Dear mentors, in this video we'll explore the 8 standards of mathematical practice, and we'll explore also the connections between these standards and the Math CEO program. So the Common Core initiative proposes an interrelated system of 8 general standards of mathematical practice which direct the attention of educators to desirable and meaningful habits of mind that engage students in authentic ways to participate in mathematical practice. When all these standards are visible during instruction and are integrated together, students will be in the best possible environment to learn mathematics. So this is a navigational guide, the Common Core standards, for what it means to do math in a meaningful way. So we'll explore these standards. Let's start with this quick activity. For each of these 8 practices, the 8 pictures that you see, or professions, however you want to see them, which skills are required. So I'll give you some seconds to think about each and try to connect it with math. What should be the relation? So, as you may have guessed, these 8 correspond to the 8 standards, so these 8 pictures. And so let's see quickly which are the 8 standards. So the first one, make sense of problems and persevere in solving them. It's like a climber that, he wants to climb that mountain, he has the tools, and he'll make sense of it, and he will not give up. That's the first standard. The second one is reason abstractly and quantitatively. So that means like a scuba diver, you get into the water and you can go with the flow and you are fluent. You can actually move in this ocean called mathematics. You can reason with numbers, etc. Third, construct viable arguments and critique the reasoning of others. So this should be kind of like an architect or somebody that's making plans that can look at other plans and critique them, can construct new arguments. So it's kind of, how am I going to do some math? What arguments am I going to use? What logic? How am I going to move in this new world? 4, model with mathematics, and this means actually building the model, so building some system that can allow me to do mathematics. So think of it as an artist that is creating some masterpiece, and it has some meaning, but he can actually, or he must actually refine it, and he has to check with the real world and adapt each time. So this is a tough job. This is one of the important standards of practice. 5, use appropriate tools strategically. So think of a carpenter that knows all the trades, knows all the tricks, has experience in using these tools, knows the limitations. So that would be the 5th standard. Then attend to precision. Think a dentist or a surgeon that, is careful, knows the steps, and knows the language very well. So this applies to math. The 7th standard, look for and make use of structure. Think of a detective that follows some clues, looks for patterns, and is just sufficiently skilled to be able to navigate and to get moving. Okay, has some techniques, have some strategies, knows which works and which don't, has a database, etc. And finally, one standard that kind of encapsulates them all, it's look for and express regularity in repeated reasoning. So this is a more mature type of standard in the sense that, like an orchestra conductor, you know what's really going on. You can streamline processes. You have some mathematical maturity. When you reason enough, you'll just know how to make it more efficient and more concise. So that's the 8th standard. In this video, we'll explore the first 4 standards, and in a second video, we'll explore the last 4. So let's start with the first one, make sense of problems and persevere in solving them. So this relates to your disposition and your ability for solving problems. It means understanding the problem, making a plan to solve it, using different problem-solving strategies, which people also call them heuristics, reflect on your answers and solutions, see if you're happy with them, how can you make them better, do they make sense, and also really embrace challenges. So be happy about learning new things, be happy that you don't know the solution yet to a problem. So it's sending this message that math shouldn't really be easy. It also shouldn't be hard, but it should be challenged. You should grow from math. It should make you, feel that you're actually learning something. You're getting challenged. So this standard goes in that direction. The second standard is reason abstractly and quantitatively. And like the scuba diver, you just enter into the water, which is the language of math, and then you can dive with no problem. You're comfortable there. You're fluent. So this means representing situations using math. So manipulate the representation on its own, right? Because some representation may come from the real world, but this standard has to do with being able to enter into that system and just be able to move into that system on its own. You can also use it to check back for solutions. That's also important. The scuba diver sometimes has to go out and check if everything's correct, so that's also important. And finally, understanding the meaning of quantities, the meaning of numbers and values. Don't just use them to perform operations, but also use conceptual understanding. And this should involve units and also understanding what I'm adding, why am I adding or subtracting, or what am I multiplying here? What's the real meaning of these operations? The third standard of practice, of mathematical practice, is construct viable arguments and critique the reasoning of others. And so you should think like an architect here, a math architect. So using definitions, dealing with conjectures, either making them or testing their validity, reasoning with uncertainty. So that means involving cases. So if this happens, I should do this, but if this happens, I should also do that, which is something that architects also need to deal with, right? Reason inductively, so from particular cases, be able to generalize or to look for more general principles, and also compare arguments from others and be able to give explanations. When you make plans for something, you should actually, have solid evidence or why you're doing that. So that's the third standard. The fourth standard is model with mathematics. So in general, we have the real world, and then we represent this real world using a mathematical model. And we want to go back and forth between the real world and the model. We just don't forget about the real world. We use the model, and then we check it with that. So you could think of this as an artist that is building, or a sculptor that is building some representation, and it always checks for updates. It always wants to make it better and refine it and really understand it. So this means framing problems mathematically that come from different contexts, whether it's the workplace or science or just your daily life, etc. Applying previous knowledge to make assumptions and approximations. So this means making assumptions that are reasonable enough for your problem, and also approximations that you think are going to be good enough. So that skill of knowing whether they're good or not, depending on the problem, comes with this standard. Also, identifying key quantities and their connections. That's also important to build your model. And interpreting confidently the mathematical results. When your model gives you some solution or some numbers or some results in general, you have to make sense of them. Are they good enough? Are they actually solving the real world problem? And if not, I just adjust this model. Okay, so in the next video, we'll focus on the last 4 standards. Thank you.